solve x cube plus 2x square minus 8 is equal to 0 by using regular falsi method up to 2 iterations. Now in this example we have given f of x as x cube plus 2x square minus 8. Put it as a number 1. To find the interval in which the root lies, we take the value of x as an integer. First integer x is equal to 0, so function at 0 is equal to minus 8. Now 0 is not a root, as function at 0 has a negative value. Now next value, as x is equal to 1, we get a function at 1 is equal to 1 cube 1 plus 2 into 1 square 2, 3 plus 1 plus 2 3 minus 8 minus 5. As this is a negative value, so x is equal to 1 is again not a root of this algebraic equation. Now for next integer value, as x is equal to, we get function at 2 cube 8 plus 2 square 4 into 2 8 16 minus 8 is a plus 8, that is positive value. So x is equal to 2 is not a root of this algebraic equation, though the sign of function changes for value x is equal to 1 and x is equal to negative to positive. So root of this equation lie between interval 1 2. Okay, so we get first iteration or first approximate root, as we use regular falsi method. So we know the formula x naught is a into f of b minus b into f of a divided by f of b minus f of a. As here a is a first endpoint 1, so 1 into function at second endpoint 2 minus reverse process 2 into function at 1 divided by function at 2 minus function at 1, as it appears in numerator. Now taking the values, simplification, as 1 is multiplied by function at 2 is here 8 minus 2 is multiplied function at 1 is here minus 5 divided by 8 minus 5. By using calculator we get the value of x naught as 1.3846. Now we have to check whether 1.3846 is a root or not. For that we use the equation number 1. On left hand side we get function at 1.3846, on right hand side we get 1.3846 bracket raised to 3 plus 2 into 1.3846 bracket square minus 8. Again using calculator we get the value of function at 1.3846 is equal to minus 1.5118. That means the function at 1.3846 has a negative value. That means 1.3846 is not a root. So we have to take next iteration to find root of this algebraic equation, as we use to find this root in interval 1 2. So we take 1 2 as here interval, and by using regular falsi method we find the value 1.3846 which is between 1 and 2. So we take it on this line. Now for 1 the function has a sign negative value and 2 has a sign positive value, as function at 1.3846 has a value minus 1.5118, that is has a negative value. Now you can observe that the sign of function changes negative to positive for value 1.38422. So the root of this equation lie between 1.384222. So using this interval we can find second approximate root or second iteration of this algebraic equation. So it is represented by x1. Now x1 lie between this interval having one endpoint 1.3842. So this 1.3842 is multiplied by function at second endpoint 2 minus 2 is multiplied by function at 1.3842 divided by f of 2 minus f of 1.3842 as it appeared in numerator. So 1.3842 is multiplied by function at 2 is here 8 minus 2 is multiplied function at 1.3842 as a value minus 1.5118 divided by 8 minus function at 1.3 minus 1.5118. Now using calculator you can simplify this as 0.4823, as we have asked here 2 iterations. So the first approximate root is 1.3846 and second approximate root is 1.4823 of given algebraic equation. Find approximate root of equation x square minus log of x equal to 12 by regular FALSI method, that is RF method. In solution, as we have given here, the equation x square minus log of x is equal to 12. This is an algebraic equation, but not in a standard form, as the right hand side is not a 0. So we take term of right hand side on left hand side, so we get x square minus log of x minus 12 is equal to 0. Now comparing this with standard form, here we have given function of x as x square minus log of x minus 12, put it as a number 1. Now to define the interval in which the root of this function lie, we take the integer values of x as first 0, so we get f of 0. By putting x as 0, we get 0 square minus log of 0 minus 12. As log of 0 is not defined, so we cannot get the value of this, so we take x as a next integer value 1, so we have a f of 1. By putting x as 1 in equation on right hand side, we get 1 square minus log of 1 minus 12. By simplifying, we get the value as minus 11 by using calculator. So function at 1 at is minus 11, so x is equal to 1 is not a root, so we take next integer value as a 2, so f of 2 will be 2 square minus log of 2 minus 12. By using calculator, we get the value as minus 8.69. so for f of x at 2, function has a value minus 8.69, so x is equal to 2 is not a root, as the sign of function does not change, so root of this algebraic equation does not lie between this value 1 and 2, so we take next value as x is equal to 3, so f of 3 will be 3 square minus log of 3 minus 12. Again using calculator, we get the value at function at 3 is minus 4.0986, as x is equal to 3, function at 3 not equal 0, so x is equal to 3 is not a root, and the sign of function does not change for successive value 2 3, so root of this algebraic equation does not lie between 2 and 3, so we take next value as x is equal to 4, so f at 4 will be 4 square minus log of 4 minus 12. By using calculator, we get the value as 2.6137. You can observe the value of this function is a positive, as a function at 3 is a negative, as sign changes, sign of function changes for value 3 4, therefore root of this equation lie between interval 3 4. Now the first approximation root by using regular FALSI method, as we know the formula x naught is equal to a into f of b minus b into f of a divided by f of b minus f of a. By putting the value as a3 3 into f of 4 minus 4 into f of 3 divided by f of 4 minus f of 3. Now we know value of f of 4 and f of 3, in first term, as 3 is multiplied by f of 4 is 2.6137 minus 4 into f of 3 is minus 4.0986 divided by f of 4 2.6137 minus f of 4 minus 4.0986. Now using calculator, we can evaluate the value of x2 as x naught as 3.6106. okay, so first approximate root we get. Now we have to check is this root of the given algebraic equation. For that, we put the value of this x in equation 1 on left hand side, we get f of 3.6106. on right hand side, we get 3.6106 bracket square minus log of 3.6106 minus 12. By using calculator, we get the value of f of 3.6106 as a minus 0.2474. As you can observe, function at this value is not equal to 0. Therefore, this value of x, that is 3.6106, is not a root of this algebraic equation, as function at this value is a negative in sign. So, to take next approximate root using this value of x, we define first the interval. To evaluate this root, we use the interval 3 4, and the approximate root which is between 3 and 4 is 3.6106. For 3 the function has a value negative sign, and for 4 function has a positive value positive sign. For 3.6106 the function has a value negative sign, so you can observe that the sign changes for 3.610 and for positive to negative to positive. So the root of this algebraic equation lie between 3 and 4. So root lie between 3.610 to 4. So using this interval we can evaluate second approximate root of this algebraic equation as x1 by using endpoint 3.6106 multiplied by function at 4 minus 4 into function at 3.6106 divided by function at 4 minus function at 3.6106. Now putting the value as 3.6106 multiplied by function at 4 is a 2.6137 minus f4 multiplied by function at 3.6106 is a minus 0.2474 divided by function at 4 2.6137 minus function at 3.6106 minus 0.2474. Now using calculator we get the value of x1 as 3.6442. So next approximate root is 3.6442. We have to check whether it is a root or the function. For that we use equation number 1. On left hand side we get f of 3.6442 and on right hand side we get 3.6442 bracket square minus log of 3.6442 minus 12. So using again calculator we can get the value at function 3.6442 as a minus 0.0129. So you can observe for this value function does not have value equal to 0. So 3.6442 is not a root of this algebraic equation, as function at 3.6442 has a value negative sign. So we take next approximate root using this root as to evaluate this root we use the interval 3.6106 to 4 as by using regular falsi method we take the root between these two values as a 3.6442. For 3.6106 as we have negative value of function, and for 4 it is a positive value, and for 3.6442 has a negative value. So as you can observe the sign of function changes negative to positive for 3.6442 to 4. So root of this equation lie between these two values. So we can here complete root lie between 3.610 to 4. Now using this interval we can evaluate the next approximate root, which is a third approximate root, as interval is a 3.610 to 4. So next approximate root is represented by x2. So for first endpoint as a 3.6104 multiplied by function at second endpoint 4 minus 4 is multiplied by function at 3.6104 divided by function at 4 minus function at 3.6104. By putting the values 3.6104 is multiplied by function at 4 which has the value 2.6137 minus 4 is multiplied by function at 3.610 has a value minus 0.0129 divided by as a numerator f of 4 denominator as f of 4 2.6137 minus function at 3.6104 is a minus 0.0129. Using calculator carefully we get the value of x2 as 3.645, as this is our answer of given root of given algebraic equation.